And in this lesson, I will be showing you how to use the Cramer's rule to solve a set of equations, 3 unknowns and in 3 equations. So I have a problem here, I have a question here. Using Cramer's rule, solve the equation, and these are the equations. The first thing I'm going to do here is I'm going to form a matrix. And the matrix will be formed from the coefficient of the unknown. The unknown here are P, Q, and R. So I'm going to form a matrix from the coefficient. Of course, you know the coefficient of P here is 1, coefficient of Q here is 2, coefficient of R here is -1, coefficient of P in the second equation here is 2, here is 3, here is R is -1, P is -1 also, Q is +1, then R is +3. So I'll form the matrix now. I'm going to have 1, 2, -1, and 2, 3, 1, and I will also have in the third column -1, -1, +3. I'll just write it as 3. And the unknown P, Q, R equals to, then the constant, the right hand side of the equation, we have 4, 2, and -1. But the focus will be on the coefficient matrix. So I have the coefficient matrix now. Step 1 is to find the coefficient matrix, which I have gotten here. This is the coefficient matrix. Step 2, calculate the determinant of the coefficient matrix. I will call it theta, equals to, the sign convention is positive, negative, and positive. Then I pick the first one here, that's 1, so that's a +1. Then the cofactors now, I get that by closing the first column here, and the first row I'll have the determinant, the 2 by 2 determinant, to be 3, -1, 1, 3, -2. Now I'll close up this and this, that will be 2, -1, -1, 3. Then next is positive, -1. Then the cofactors now, I close this up, I will have 2, 3, -1, 1. So I'm going to work on this now. I will have 1 into, I multiply transversely like this across. I have 9, starting from this, 3 times 3, 9, +1, and -2 next into 6. This will give us -1. This will give us -1 into bracket 2, 2 plus 3. So on simplifying this now, we have 1 into 10 -2, 5 -1, 5. So this will give us 10, this will give us 10, and this will give us 5. This altogether will be equals to -5. Our determinant for the coefficient matrix is -5. That's our step 2. Then step 3 is to get the unknown. The unknown P. I'm working with P first. To get P now, I'm going to form another matrix, and I'll replace the first column here. I'm going to replace it with the constant term on the right hand side of the equation here. I will have a new matrix now, which will be 4, 2, -1. Then all these, the remaining 2 columns, they remain the same. So we have 2, 3, 1, -1, -1, 3. So I'll find the determinant and divide it with the determinant of the coefficient matrix. That's how I'll get my P. Similarly for Q also, I'll replace the second column with the constant term on the right hand side of the equation. And for the third unknown now, R, I'm going to replace the third column with the constant term on the right hand side of the equation. So let's get P. I'll put my sign. We have this to be positive, negative, and positive. I have 4, 3, -1, 1, 3. I have -2, 2, -1, -1, 3. I have +1, 2, 3, negative 1, 1. Next is to evaluate this. I have 4 to 9 plus 1 minus 2. This will be 6 minus 1 plus minus will give us minus 1. And 2 times 1 will give us 2. 2 plus 3. So I have 4 into 9, 10, and minus 2 into 5, and minus 1 into 5. 40. This will give us 10, and this will give us 5. That's 40 minus 10, 30. 30 minus 5 will give us 25. P equals to 25, and the determinant of the coefficient matrix negative 5. So we have P to be negative 5. For Q now, I'm going to replace this second column. I'm going to replace it with this constant term here. I will have 1, 2, negative 1, 4, 2, negative 1, negative 1, negative 1, and 3. I'll find its determinant. I'll divide it with the determinant of the coefficient matrix. So I'll put my sign convention, my sign. This will be positive, negative, positive. I will have the determinant to be positive 1, 2, negative 1, negative 1, 3. And next is negative 4, 2, negative 1, negative 1, 3. So next is positive, negative 1, 2, 2, negative 1, negative 1. So evaluating this, I have 1 into 2 times 3, 6, minus, this will give us 1, minus 1, minus 4. This will give us 6 again, minus 1. Then this will give us negative 1, negative 2, and minus, that will be plus now, plus 2. So 5 minus 4, 5 again, then minus 1, 0. So this will give us 5 minus 20 minus 0, and we got this to be negative 15. So Q now, Q, the determinant of this matrix now is negative 15, and the coefficient matrix as gotten earlier was negative 5. So do this division, Q will be equals to 3. Then lastly, we get R. Okay, for R now, to get R now, I'm going to replace this column with this constant on the right hand side of the equation. R equals to 1, 2, negative 1, 2, 3, 1. Then I replace all of this with this. I will have 4, 2, negative 1. Then I find its determinant and divide it with the determinant of the coefficient matrix. So as I did earlier, I'm going to put my sign convention. Then the determinant will be equals to positive 1 is positive 1, 3, 2, 1, negative 1. Then I have negative 2. I close this up, I will have 2, 2, negative 1, negative 1. Then the third one now, I have positive 4. I'll close here up, I will have 2, 3, negative 1, 1. So evaluating this, I will have 1 into brackets. This will give us negative 3, and this will give us 2. That's minus 2. Then minus 2. This multiplies this, we have negative 2. This multiplies this, we have negative 2, minus, so that will be positive 2. Then positive 4 into bracket. This multiplies this, give us 2. Then minus, this multiplies this, will give us minus 3. That will be all positive 3. So we have 1, negative 5, negative 2, because you know this will give us 0, then positive 4, then this will give us 5. So evaluating this, we have negative 5, 0, positive 20, which will altogether give us 15. So R now is the determinant of this matrix was gotten to be 15. I divided by the determinant of the coefficient matrix, which is negative 5. So I have R to be negative 3. So I've gotten my unknown. I got P to be negative 5. I got Q to be 3. 3, and I got R to be -3. So I have P is -5, Q is 3, and R is -3. So this is the solution to this set of equations using the Cramer's rule.